Hello and welcome back to Algebra. The goal for today is to learn about factoring, and this is introductory lecture. We are only learning greatest common factor and the first two methods of factoring, GCF, which is greatest common factor, and factoring by grouping. Now, before we go into any of those, what is factoring? Well, when you have multiplication and you say 3 times 5 equals 15, these two guys are called factors. And this one over here is called the product, which is the answer of multiplication. Now, factoring would be starting at 15 and breaking it down to 3 and 5 so that you have 3 times 5 is 15. So the process of breaking a product into factors is called factoring. And this is literally anti-chapter 5. Because in chapter 5 you multiply either numbers or expressions and your product is the answer. Now in chapter 6 you're starting with the product and you're supposed to break it down into the components that are called factors. So factoring is the process of breaking down product into a number of factors. Why do I say number of factors? Because it's not just guaranteed that you are going to have two factors, right? You might have more than that. If you take a look at, let's say, number 18, you can break that into 2 times 9, and then 9 breaks into 3 times 3. So 18 is 2 times 3 times 3. That's what 18 is. 2 times 3 times 3. So it has 3 factors. Well, 15 had 2 factors. So you can have 2 or 3 or 17 factors. Depends on how complicated, right, the problem is. So your job is to learn in chapter 6 to some extent, because the other half of our chapter 6 is intermediate algebra. Obviously, if you don't take that class, you won't learn all of it. So your job in chapter 6 is to learn some of these factoring techniques, which are very straightforward, but you really have to learn the rules so you can go back, right? And it has more to it than what you had in chapter 5. But technically, we are undoing chapter 5. Now, I'm going to give you an example of chapter 5 versus chapter 6. So in chapter 5, well, actually, no, let's do it this way. You had x plus 3 times x minus 6. No, let's go with the 8. Is equal to, and then you would get your answer as x squared minus 5x minus 24. So if you are to go and FOIL and do all of those steps that you learned in chapter 5, you would be able to multiply two binomials and obtain this answer, the product at the end. This is something that, right, this is basic foiling from 5.3, and everyone should be able to do this quickly. Now, when you do the problem this way, you have chapter 5. When you do the problem this way, you have chapter 6. So in chapter 6, this is given, and then you are breaking that apart into smaller pieces. Now, in elementary algebra, we are going to learn let's say 4 out of 5 factoring techniques, leaving that most challenging one for intermediate algebra. So we are going to learn, number one, I'll write the abbreviation GCF, which stands for greatest common factor, but that will be a title soon. So GCF, grouping, trinomial of the form, trinomial of this form, and then 4 special cases, which is obviously your special products. Remember those 3 formulas? That's going to be in here, and obviously that's going to be actually next week for us. So we have these guys. These two are in 6.1. This is your 6.2, and this is your 6.4. So this is what we have as a map for our chapter 6. There will be an extra section later, but that section is application of factoring to solve equations. So it's not something that we consider, it's not a method of factoring, it's using the factoring to go on. All right, so we are now hopefully ready to talk about greatest common factor. This is our title. As I said, 6.1 will contain greatest common factor, and it will also contain factoring by grouping. So to start off, greatest common factor is the most important factoring technique. It's most frequent as well, and you should always look for it first before you consider any other factoring technique. Greatest common factor is collecting from each term parts, like factors that are common in between all of the terms that you are considering. So to start this with a very easy problem, we will consider 15x squared minus 5xy, for instance. Let's say this is the expression. The question is, what are these two, right? We have a binomial here, term number 1, term number 2. So we have 2 terms. The question is, what are these terms consisted of? Right? What are the factors that are parts of each one of these? And those are 3 times 5 times x. So, and this one is already written as the simplest form. There is nothing, you can't break anything apart. So when you look at the first one, number 15 is a number that we can break down into 3 times 5. And then x squared can be written as x times x. And now our goal is to find what we call the GCF, which is, and I'm going to call it stuff. We should call it numbers and variables, right? But I'm just going to say, find the common stuff. What is in both of these? Now, right, it takes about 7 IQ to say, oh, 5 is in both of them. Okay, 5, that's great. What else is in both of them? Well, one of the x's is in both of them. Okay, so we have found the greatest common factor. The greatest because we took the most out we could. We didn't take just 5 or just x. We took 5 and x. That's the most we can take from both. And that's why it's called the greatest. Now, common, meaning it's in both of these terms. Later, if you have 3 or 5 terms, it has to be in all of those terms. So, greatest, it's the most you can take. Common has to be in each one, and then factor is obviously, right, because they are all multiplications in here. Now, technically, what you have done here is you eliminated those out of those terms, and technically you just now have a 3x minus y, which is what I called a leftover. All right, a leftover. Think about like a Thanksgiving dinner and just have a leftovers, and then you just make sandwiches for next 3 years with the leftovers. So I don't know if am I the only one who absolutely hates Thanksgiving meals with a turkey and dry food and I don't know. What I am now that's the invitation for me to join the Thanksgiving place at your stuff, because when someone says, "Oh, let's have a turkey," I was like, "Why? You can do literally anything else." Plus, apparently, turkey makes you sleepy as well. Yeah. So how about we all over here start a movement and let's say let's roast pork or something for Thanksgiving. Oh my! I just have a completely newfound respect and love for this class. I mean, I thought that I was, because everywhere else, literally, I would talk about this. They was like, "No, you're insane. We have to have a turkey. It's a tradition." I was like, "Yeah, right, but still, it's Anyway, so how did we actually got? Oh yeah, because I talked about leftovers. For a moment, I got concerned, like how we got from 15x squared minus 5x to roasting pork for Thanksgiving. No. Or maybe it would. I don't know. So what we have is now factored expression. Now, why is it called a factor? Because there is this big fat multiplication sign in between factor number 1 and a factor number 2. They multiply together to create this product. Now, as a student of mathematics, who was terrible at the beginning and then just woke up at one particular point in time, I always liked better sections and concepts that I can check than those that I can't. So we always, right, say that, and it's obviously clear, that chapter 5 should be easier than chapter 6 because you just multiply and you move along. Where chapter 6 you have to learn all of these hoops, right? But I like chapter 6 better because I can check my answer and I know for a fact that I did it correctly, which is something you can do in chapter 5, right? In chapter 5, you multiply, and if you missed a sign, you missed something, well, yeah, you're gonna be marked off for that. Now here, if you are not lazy, you can do this and know 100% of the time that you are correct, because all you need to do is to distribute this 5x into this parenthesis, and you will get 5 times 3 is 15, x times x is x squared, minus 5xy, which matches your problem, and you know that this is 100% correct. So this is technically what we will be doing with this section. So we're going to dig into these expressions, find what's common, kick it out, and then have the leftovers end up in the parenthesis. So let's go with 6y cubed minus 2y squared. Let's not do 2y squared yet. Let's go with 30, whatever. There is a reason why I don't want that yet. We'll discuss it soon. All right, so let's break these apart. Now, we already see that 6 is a part of 30. I know I can break 6 down into 2 times 3, but I'm not going to do that because the 6 is the part of 30. I can write 30 as 6 times 5, and then I can just kick 6 out. So I'm going to leave 6 and just write y. minus, and here's the 6 times 5, yy. So sometimes, right, you want to go all the way down to 2s and 3s and 5s and so on, and sometimes you don't have to. Now, you wouldn't be wrong to go down to 2s and 3s, because you would go down to 2 and 3 over here as well. Then you would pull a 2, and you would pull a 3, and you would have 6 anyway. Right? So these are the little, finesse moves that you will get used to when you do 1,000 problems. Right now, everything is new, obviously, so we have to build up to there. Now, I need you to list what's the GCF. Did I hear word X? I mean, letter X? Oh, 6. I was like, X? What? There are no X's anywhere. Okay, good. Whew. That's just my terrible hearing. So, okay, so 6. Is there anything else that is common between the two terms? YY, which we are going to call y squared. Perfect. Now, once you pick out what's common, you can just cross them out, and we have our 6y squared in a parenthesis, y minus 5 are the leftovers. We're done. It's always this simple. Break it down, pick the common stuff, put the leftovers inside the parenthesis. Break it down, pick the common stuff, which is a GCF, and then the leftovers go into parentheses. I'm going to run into the back of the book and take a look at some of the problems that they pose there. So the next 3 problems will be all you guys. 3x squared plus 9x. This is problem 15. Go. If you just want to say the answer, that's fine, without the work. You will be skipping work very soon because it's... Excellent. Excellent. Because 3x times x is 3x squared, and then 3x times 3 is 9x. Excellent. Now, to break it down, it's 3xx plus 3 times 3 times x, and your common stuff, 3 with 3, and 1x with 1x. The leftovers are the ones that are not taken, which means they are they go in a parenthesis. Very good. The next problem will have 3 of these to worry about. Problem 20. It says 5x to the 4th minus 15x cubed minus 10x squared. I don't know. It would be really amazing if it is, because this would be a two-step factoring in that case. So let's discover it together. I definitely love this. That's right. That's all. That's given. This part that we have to verify, but I think it's perfect. So here we go. 5xxxx minus 3 times 5xxx minus 2 times 5xx. So each one of these has a 5. Kick that out. That's the 5 and then 2 x's in each. So that's our x squared. So right now we are at 5x squared, and we have x squared minus 3x minus 2. Unfortunately, this doesn't work. Unfortunately, this needs to be a plus, and then we would have x minus 2, x minus 1 in that case, if that was a plus, but it's not. I think they purposely put these ones, but again, good thing for trying, and we will be learning this next class. So yeah, we'll be fine. But great job on getting this. One more for these. Well, actually, we can actually get more of them. Actually, there's a whole other section here. Perfect. Let's start with problem 22. 7x cubed y cubed plus 14x squared y squared. No coffee. Something I used to say like for 2 years or maybe in a row as a joke, and now it turned out to be, the worst thing ever if someone coughs. Of course, but again, there's no reason to redeem. I mean, you're learning, so it's all good, man. Awesome. Awesome. So that's 7xxxyy plus 2 times 7xxyy, and the common 7 that goes there, 2 of the x's, 2 of the y's, and the leftovers are this x over here, this y over here, and this 2, so xy plus 2. Excellent job. All right, now let's put a little twist on all of this. Not a twist, but it's a mistake that kind of creeps up and ruins your grades. So let's take a look at 16 x squared y squared minus 4xy, for instance. So this is the same as before, right? There's nothing special there. You have your 4 times 4, you have your x's, you have your y's. But now, look what happens. When you pick your GCF, you will pick a 4, and then x, and then a y. And do you see that everything is gone from the second term? Right? So when that happens, you have to put 1. And I like to call it a placeholder. Okay? I like to call it a placeholder. I'll write it in blood here. And the reason is, it was before I called it a placeholder, I used to call it a grade slayer. So I think the placeholder is has a little bit more of like a positive note to it, rather than a grade slayer, right? So why is it there? Well, think about checking this problem. Right? If you put nothing there because you say, oh, I took everything out, so it's just I don't write anything. Then when you try to check this problem, this would multiply there and you would get this back, but then, right? You're stuck. There's nothing to give you the second term back. But if you have a 1 there, then that would distribute there as well, and then you would get your second term as well. So, yeah, I am. So if I want to check this, 4 times 4 is 16, x times x and y times y. So that's, right, this goes as a unit here, and then it goes as a unit there. And when it goes as a unit into this one, it produces the second term. So we have to put this, and you can write that as a rule. Every time when you factor out everything out of a term, number 1 stays behind with whatever sign you have in front. Now I'm going to give you more examples of this so that you know what's happening. So let's go with another example. So we're going to go with 48 x squared y minus 12x. That's it, minus 12x. We have the same thing. 48 is 4 times 12, xx, a y, and then minus 12x. Do we all see that 12 is common? So 12 goes on the list. Do we all see that x is common? That goes on the list as well. And what's left is 4xy minus, again, 1. I have to put this placeholder there because everything was factored out from the second term. And now you are going to distribute everything back to check and get the answer. So when you multiply it like this and like this, you get your 12 times 4 is 48, x squared y, minus 1 times 12x is 12x, and everything is back the way it's supposed to be. Yeah, that one is, as I said, I used to call it a grade slayer. Because anytime it shows up, right, students that don't pay attention in class, they don't learn, they don't study it, yeah, they all get it wrong. So it's very important. It shows up also in problems that would have GCF, right, where you can just pull, let's see this one. 5x squared minus 25x plus 5. So what is the GCF? What would be the GCF for this one? 5. That's it. Just number 5. And then the rest is x squared minus 5x. And here is the plus 1 at the end. That plus 1, again, is the placeholder, something that we want to have because we need to multiply back into that number. Yes, exactly that. That's what chapter 6 is. That's what chapter 6 is, right? That it's a reverse of chapter 5. All right, so now that you know all of this, I'm going to raise the stakes just one more time. This time we are going to have the entire expression factored out, which sets us up for our next part. And that is, if you have, let's say, x, get out of here, x times y minus 3 plus 4 times y minus 3. Do we all agree that there is something common? Y minus 3. So I need you to see that as a unit, right? And you get to factor that y minus 3 as a GCF. And then the leftovers, which are x plus 4, goes in a parenthesis. So technically, right, this is a unit. This is one term. And this is the second term. And these two terms have something in common, right? The entire parenthesis is GCF, greatest common factor, because it appears it's identical, right? In both of these, it's the same. And it appears in both. Therefore, we factor that one out, and then when you cross it out, right, because you factored it, the leftovers are x plus 4 for the parenthesis. So these are usually a little bit harder to see in the beginning, but once you get used to it, it goes quick. So let's say you have AB times x plus 6 minus 4c x plus 6. What is common? X plus 6. And now what are the leftovers? AB minus 4c. Okay, one more of these. So let's say you have AB squared of xy minus 3 minus b xy minus 3. Now this is the evil problem. That last parenthesis a minus b is not good. So, I'm sorry? Yeah, it's not a minus b. It's not a minus b. So let's start from scratch, where you said that you are going to find b in common, and you are finding xy minus 3 in common as well. That's all good. So if you are to cross those, so you cross this, that's there. You cross b and one of the b's, so you can just kill the square. What's the leftover for the parenthesis here? AB minus 1, yes. There's evil. I detailed here. I'll spell it out. There we go. Because did we take everything out of the second term? Right? We took out everything, and that's why we have that minus 1 there. So yes, this is the evil problem, and yeah, we'll leave that there. Okay, now we get to practice this even more, because the next title is factoring by grouping. So we are going to group the terms together, and then we're going to do the GCF, which will actually lead us into this situation from before. Now, you are going to recognize factoring by grouping because those problems have 4 terms. I'll write it in, I guess, purple. Problems have 4 terms, because you will be grouping it into two groups of 2 terms. So let's start with probably the simplest example in the galaxy, which is x cubed plus x squared plus 2x plus 2. Remember what this purple thing said. 4 terms. 1, 2, 3, 4. 4 terms. Awesome. Let's go. Factoring by grouping. I'm going to group the first 2 and the second 2 terms. Actually, I just realized one thing, that if I do that here, then you don't see this problem, and so I'm just going to copy the problem one more time. Maybe it would be good for you in notes to do the same thing, because me placing these parentheses, that's a step, right? So you have a problem, and then you decide to group. All right, so now we do the independent GCFs. The first one kicks out x squared, right? And left with x plus 1. Do we all agree with that? Kicking out x squared and leaving x plus 1 behind? If anyone has a question or a problem with this, we need to know and address it right now. If not, then we are moving on. Well, the x cubed has 3 x's in it, right? Okay, good. So now that we have that, we move to the next parenthesis. So there is this plus, and in the next one we are kicking out 2, which once you kick 2 out, you are left with x plus 1. So now you see that thing x plus 1, the plus 1 placeholder appearing in both of these parts, right? Both terms. All right, now we're pretty much done, right? We have one more factoring to do because now both of these have x plus 1 as a common. So now we collect x plus 1 and put those two together, and then we are truly done. So x plus 1 is now common, leaving x squared plus 2 as a leftover for the second parenthesis. I like to connect these like this so you know that those are common that go into the same group. And there you have it. So look, stare at it a bit more, and then we're going to do more examples. Now, in some of these cases, we will have to rearrange the terms and so on. Now, we're going to work on those examples as well. Some, you can just go immediately with these parentheses and separate, and in some, you will actually have to rearrange the terms and then do the grouping in a different order. But again, you will be able to see those problems because you will not be able to group and pull anything out because they will have nothing. Yes? Okay. X squared is right here. You mean this? That is what is factored. So when you look at this, okay, let me just erase all of these lines, and I'm going to put them in boxes. So this is your first term, and this is your second term. Now, what do they have in common, right? The GCF is the x plus 1. So when we factor that one out, right, we kick it and we put it here, what is the leftover? The leftover is x plus... no, x squared plus 2. Does that make sense now? And this is, okay, good. And so this is what my line, this is what this means, right? That I collected those two terms, right, on a pile, and I factor that out, creating what we call a common term. Now let's work more on these examples. So technically we are done because this is our this is everything that we are supposed to work on, right? Factoring by grouping and GCF and factoring by grouping. Now let's take a look at some of the problems from the book. So 3x plus 3y plus ax plus ay. So when you group the first two and you group the second two, let's see what you get. Do we have any offers? Well, what can we kick out from the first? What do we get to kick out from the first parenthesis? No, it's just a 3. That's the common 1 3. So we just kick a 3, and left over is x plus y. Now what do we kick from the second parenthesis? Just a. Because again, when you are pooling them, right, you cross what's common. So you only have one a in each, and you kick them out together. So the leftover is x plus y. And now, as you mentioned, x plus y is common, leaving what is 3 plus a. You can write a plus 3, but 3 plus a is fine as well. Okay, so these make sense? Well, for the rest of the period, this is what we're doing. We're just dealing with these. We don't have anything else. So let's take a look at more of these. Another one, again from the textbook. 2x to the 5 minus 8x to the 4 plus 6x to the 3 minus 24x squared. Two x to the 4 minus 6x squared, like this. All right, let's take a look. I hope it is. I hope it is. So what we are going to do is we're going to group them, and then we're going to kick 2x to the 4th because this one has 4x's and this one has 5, so I can kick out 4x's. When I kick out 4x, okay, good. So now 2 is out, so 1x stays, minus 4. What do you mean? Got it? Yes. Yes, it's just x right there. Right, that's the leftovers. So when I have 5 x's, minus 8, 2 times 4, and then 4 x's, right? When I kick out a 2, which is in front, 1, 2, 3, 4, 1, 2, 3, 4, the leftovers are a single x and a single 4. Cool. So now for the next one, we are kicking a 6 out, so plus 6 and then x squared, leaving us with x minus 4. You got it, man. Awesome. Now x to the 4 is common, and then 2x to the 4 plus 6x squared. That was boss move right there. All right, let's do some from homework. So these are the homework. Now remember, at some points here, at this point, you will have to rearrange the terms. 6x cubed minus 5 minus 10x plus 3x squared. So you have to rearrange terms in this one. Any luck? We have to rearrange this, right? So, okay, please. Aha, okay, so it's not, I thought it was the right answer at the end. I mean, final answer, but it's not. Okay, so let's take a look, and then you follow along and tell me if you got it right on that step. 3x squared, and then minus 10x, and then minus 5. So what I have done here is I have arranged these terms from largest to the smallest exponent. And now, when I do grouping, the minus sign belongs to the 10, and then I'll put the plus in between on my own. So we kick out 3x squared, this is what you said, and then 2x plus 1, that's what you had, I remember, right? And now you kick out minus 5, and when you take minus 5 out, see, negative 10x divided by negative 5 leaves positive 2x, because negative cancels negative. 10 divided by 5 is 2, so we have 2x. So it's 2x plus 1. Now, these factorings, when you have to work with the negative, usually confuses people. So we'll have to do more examples of that one. If it helps, you can do the division on the side. Technically, factoring is working on a division because the leftovers are what you are left with once division is done. That's why also when you factor out everything, 1 stays behind, because you're dividing it by itself technically. Let's take a look at the final stage here. So now I have 2x plus 1 as a common, and then I have 3x squared minus 5 in this parenthesis. So we had a couple of these issues. I don't know if I should call them issues or I should call them interesting things or whatever. The negative belongs to the 10. That's one of the key points, because we need both of these terms in the second parenthesis to have the same sign, because both of the terms in the first parenthesis have the same sign. So you can't have one parenthesis with different signs and the other parenthesis to have same signs. Then they wouldn't factor into the same parenthesis at the end. So we have to have them with the same sign. And then later on, when you get very good with this, you will also be grouping these by trying to put the signs together as well, not just what you can kick out. Let's take a look at more of these with negative signs. Seven x cubed minus 6 minus 2x plus 21x squared. So let's see what you can literally follow the steps from a previous problem. Wow, I just got email, guys, that someone wants to send me $10.5 million. Yeah, look like this. Wow, they say, wow, this is great. They're sending everything, all the information, and they just say, we decide to contact you through your email address because we have our bank records, can make the transfer into this account. We appreciate if you confirm that you are alive by sending your contact direct. Okay, good. Good, good, good. Well, you know what I do with these emails. You always go one way, and that is I'm in. This is gonna be an awesome week of emailing back and forth. That's when you're bored, you have nothing else to do. Just email back. I'm in. Let's see. Let's see how far this is gonna go. I hope you all rearranged into descending order and then grouped and put the plus in between. Right, keep that minus with 2x so you can kick it out with the rest. All right, so what do we kick out from the first parenthesis? 7x squared is correct. Excellent. Now, what are the leftovers? X plus 3. Excellent. Now, what do we kick out from the second parenthesis? Excellent. And now, the leftovers are x plus 3. Now, y? Negative 2x divided by negative 2 is just x. And negative 6 divided by negative 2 is positive 3. So x plus 3. When you are factoring something out, you're technically doing the division. Now, if you don't like that division part, you can also go back to what we used to do before. Negative 2 times x, and then negative 2 times 3. We are kicking out negative 2, so what's left is x and the 3, x plus 3. So now x plus 3 is common, and the leftovers are 7x squared minus 2. And now let's do one more. Now I would ask you to be a little bit careful with this one, because there is something special happening here. I hope you catch it. 6y to the 4 minus 24y cubed minus 2y squared plus 8y. Does anyone see something interesting? Yeah, well, we have y's. It's already in descending order. That's not what I'm looking for. No. But you are tempted to immediately go and put your parentheses, right, for grouping, right? Now, why are we not doing this? We can, if you pay attention to the problem, right? We can take the GCF before we start grouping. And that is something that people usually don't see, and then their problems become harder. If you take a look at each one of these terms, you can actually kick out 2y as a GCF from them. Because this one has y 2 times 3, and then 2 times 12, and then 2, and then 2 times 4. So we can start this problem by kicking out 2y, which leaves us with 3y cubed, 3y cubed minus 12y squared minus y plus 4. And then we just have to worry about this and see if we can factor that further. So that GCF that we studied first will always be something that you need to check first. And if you can, you will use the GCF first, and then you will go with grouping and all other techniques that I listed at the beginning of the class. Now, we also have a little bit of an issue here with the problem, being that these negative signs are not cooperating with us, but sometimes such is life. So we're going to group this the way we are used to. There's a plus in between. And now when we start factoring, we always have to copy this 2y in front. So from the first I can kick out 3y squared. I hope you all see the 3y squared because 12 has a 3 as a part of it, as a factor. So what we have is kick out 3y squared and we're left with y minus 4. And now this is like a $1 million step. Look at you have y minus 4, but the other parenthesis is minus y plus 4. It's backwards. Now you fix the backwards parenthesis when you kick out minus 1. Then you get y minus 4. That is the step that a lot of people unfortunately doesn't know. So if you have a minus b, you can factor out minus 1 and then have it as b minus a. My goal was to change all of the signs in the second parenthesis, right, in here. My job was to change those signs so they can match these ones so that I can factor them. Now they have the same order, same sign, everything is the same, so I can factor them together. That is, again, now this stays as a YouTube lesson, obviously, so you can go back and review this time and time again. We only have 1 minute left for the class. So I'm just going to write the answer here and hope that you will go back and rewind this couple of times. So once I did the switch, because I factored out negative 1, now the two parentheses are the same, and when I put them on the pile, meaning factoring them and eliminating them from the terms, the leftover is 3y squared, and then those are the leftovers, minus 1. So this problem is tricky because of this situation where the signs did not cooperate. And you will always have that situation when you have the outside pluses and inside minuses. You can't avoid it. So this is some I'll put the sideways formula. It's not a formula that anyone teaches. It's just the fact of switching factors gives this. So yeah. And there we have it. So that was the introduction to factoring. We learned GCF today, which we will be using in every section. And then here and there we might run into grouping as well. Grouping is rare. Problems are made specifically for it. What we learn next class is going to be the most important, along with GCF. Now GCF is, as I said, something you always try first, and then you go with other techniques of factoring, and we'll deal with that when we get there. Questions, concerns? Anything you would like to add or subtract on this? No? Well, we'll say goodbye